with number 1. Okay, you know that these problems will be on the test, correct? Not the exact. Okay. So I'm given a function which is 5 plus 54x minus 2x cubed. I'm given a restricted domain, and I'm asked to find max min. You have something like this in your notes, correct? Okay. So first of all, I will get the chart going. If you like to use the chart, of course, have f prime, and I have f of x. And I will definitely find f prime, which is negative 6x squared plus 54. I will factor out negative 6, and I have x squared minus 9. Good. And this is negative 6 and x minus 3 and x plus 3. When I set f prime equal to 0, I get at 0. I get it equals x equals 3 and x equals negative 3. However, this is not in the domain. So just 3. I have to write 0. I have to find f of 0, f of 3, and f of 4. So f of 0, f of 3, and f of 4. And before I even do that, I have to study the sign of the first derivative. It's a quadratic function with a negative leading coefficient, so it has a maximum. So it's between the solutions, between negative 3, which is not here, and 3, it will be positive, and outside will be negative. Or you plug in a number. So now I grab my calculator. I put in this function. Obviously, when x is 0, y is 5. There is no discussion there. But then I have, it's 5 plus 5x minus 2x to the third. And when I plug in, what am I plugging in? 3, and I'm plugging in 4. I got negative 34. Why did I get negative 34? It makes no sense. So 5 plus, oh, yeah, because I wrote 5 instead of, okay, sorry about that.
113. Yeah. And the last one.
Very good. 113 indeed. 113, and the other one is 93. I see that 5 increases to 113, and then from 113 down to 93. And obviously, so this is 5, this is 113, and this is 93. So 5 is here, 113, so this is 5, 113, and then 93, which tells me that this is a local max and absolute max, local and absolute max. And it tells me that this is an absolute min, and this is nothing. Is this clear? Any questions on this problem? Okay, here is the second one. In the second one, we were given a function that is natural log. Okay, natural log x on the interval 1, 4. They're asking us to show that it satisfies the hypothesis of the mean value theorem, and then find C that satisfies the conclusion of the mean value theorem. And here there are only 2 hypotheses. So we know that f is continuous because log function is continuous everywhere, especially on 1, 4. And f is differentiable on the interval 1, 4. Log has no corners, no cusps, it's continuous everywhere, and it's differentiable on 1, 4. Okay, so therefore, I will conclude that by MVT, there exists C in the interval 1, 4, such that f of b minus f of a divided by b minus a equals f prime of C. So f of b is natural log 4, f of a is 0, divided by 4 minus 1, which is 3, which equals 1 over C. I flip both sides, So C equals 3 over natural log 4. I will punch it in the calculator to make sure that it's between 1 and 4, because anything can happen, right? Natural log of 4. So I got 2.16. Yes, is indeed in the interval 1, 4. And that was the second problem. Any questions on the second problem? Okay, the third problem. In the third problem, we're asked to find the limit as x approaches pi over 2 from the left from tangent x raised to cosine x. And yes, like always, I have to plug it in. I remember the graph of tangent, which is this, with negative pi over 2 and pi over 2. So pi over 2 from the left, pi over 2 from the left, so this approaches infinity, and cosine pi over 2 is 0. This is one of the biggest problems possible, right? Infinity raised to 0. So I'm going to say I will let y be tangent x raised to cosine x, and then, very good, natural log equals cosine x multiplied by natural log of tangent x. Now I apply the limit to both sides. Limit as x approaches pi over 2 from the left of y equals limit as x approaches pi over 2 from the left from cosine x times natural log tangent x. Now I check again, see what I have. Cosine approaching pi over 2 from left or right, it doesn't matter, this is 0. And this is infinity, right? And natural log of infinity is infinity. So this is more human. 0 times infinity, it is more human than infinity raised to 0. Good. So now I just need a manipulation. That's just an algebraic manipulation somehow to get it 0 over 0 or infinity over infinity. So therefore, I continue. So then I have limit as x approaches pi over 2 from the left. Never bring natural log down. It will be a total mess. So instead of cosine over 1, I will write 1 over cosine x. So now this is infinity definitely, and 1 over 0 from positive 0 is infinity. Not that it matters, but it's still infinity over infinity, and I like this. But not before I change. I don't want to differentiate something like that. So I will change 1 over cosine into secant x. So this is natural log and tangent x. Now, since it's infinity over infinity, I can apply L'Hopital's rule. So then I have limit x approaches pi over 2 from the left, 1 over tangent squared, 1 over tangent times secant squared x over secant tangent. So I will simplify as secant. And then I continue with limit as x approaches pi over 2 from the left, secant over tangent squared, okay? And I know that I can replace this. So we know that 1 plus tangent squared x equals secant squared x. So if I write secant squared minus 1, replacing this, let's see what we get. So limit x approaches pi over 2 from the left, secant x, and secant squared minus 1. So now pi over 2 from the left, so pi over 2 from the left is 1 over 0 from the left, so this will be infinity, and this will still be infinity, but I don't really like it because I have a square in the denominator. So I'm going to come back here for 1 second and see if I can simplify this in any other way. This is 1 over cosine. Yeah, I think I should do 1 over cosine multiplied by cosine squared over sine squared. Yes, I should do this instead of that. So it's cosine over sine squared. Okay, so instead of this, I'd rather use cosine over sine squared. So limit as x approaches pi over 2 from the left, cosine x divided by sine squared x. And this is done because the top is 0 and the bottom is 1, so this is 0. That was the easiest thing to do. So when I come back to the problem, I know that limit of, I meant to say to write natural log here. So a limit of natural log is 0. So I will copy the beginning and the end. So I have limit as x approaches pi over 2 from the left from natural log y is 0. Now I'm allowed to swap. So then natural log of the limit as x approaches pi over 2 from the left of y is 0. So what should this be so that the natural log is 0? And the answer is 1. So I come back to the original problem, and I know that the answer is 1. No, you could have not concluded that infinity raised to 0 is 1 from the beginning. Any questions on this problem? Yes, Sarah, go ahead.
I got 1, but I did something completely different.
I have to take a look at it. Okay, any questions? But please do this on Wednesday, though. Whatever you did on the quiz, do this on Wednesday, okay? Please, please. Okay, should I still keep it up here?
Oh, no.
Okay, so now the last one. F of x equals x minus natural log x. Okay? So I said everything. Good. So first of all, I have to start with the domain. I know that the domain is greater than 0. So when I get the chart going, I will have 0 to infinity. And of course, a vertical asymptote at 0. So f prime of x, f of x, and the second derivative. Okay, so I need this, and I need the x and y intercepts if they exist. In this case, x is greater than 0. So there is no y-intercept. I can plug in 0. No x, no y-intercept. So now f of x equals 0 means x minus natural log x is 0. I know how to determine the solution here with a super accuracy, right? So I'm going to say this is my g of x, which is x minus natural log x. G prime of x is 1 minus 1 over x. So then I know that the function I need to use Newton's method on will be x minus natural log x over 1 minus 1 over x. I don't know where to start. So in y equals, I will put in x minus natural log x. And I will plug in, of course, 0 I can't. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, it appears that it moves away. 9, 10, 11. Okay, so I'm checking what I wrote in here, just making sure. X minus natural log x. Okay, it appears that this function doesn't have an x-intercept. Okay, so then I will determine the limit as x approaches 0 from the right. Of course, sorry. So as x approaches 0 from the right of x minus natural log x. So this is 0, and this is 0 from the right will be negative infinity with minus in front is infinity. And now limit as x approaches infinity from x minus natural log x. And this approaches infinity. This approaches negative infinity with minus in front. It will be infinity because infinity plus infinity is infinity. There is no indeterminate case here. Fine. Okay. Good. So now I have the first derivative, which is 1 minus 1 over x. So f prime of x is 1 minus 1 over x, or x minus 1 over x. And I know that f prime is 0 and x is 1. So at x equals 1, I will put 0. Now I have to study the sign. But this is always positive because the domain is 0 to infinity. However, x minus 1 is a linear function with a positive slope, so it's coming from negative and going to positive. Sure. Oh yeah, I put the 0. Okay, sorry about that.
So you have.
So this is when x is 1, this is 1. I put the 0 in the wrong spot.
So the limit as x approaches infinity. Could you go back to that?
Yes, please.
So you've got.
Oh yeah. Oh, I'm sorry. So this is positive infinity. So infinity minus infinity. Sorry about that. No. No, infinity. So yeah, for some reason I was still on 0. I was still on 0 in my mind. So infinity minus infinity is an indeterminate case, which means I can't. I cannot use L'Hopital's rule. However, if we graph, I can't use L'Hopital's rule on infinity minus infinity, and there is nothing I can do to x minus log x. I cannot change it into 0 over 0 no matter what I do, and I cannot change it into infinity over infinity no matter what I do. So I have to analyze. So I have to analyze this. Okay. So remember, x is this function, right? So when we graph x, we graph this, correct? So this is this side, which is x, right? Just x, y equals x. Now when I graph natural log is this. Which of these two goes faster to infinity? Right, x will. That's the reason why the answer is infinity. But I cannot conclude because I cannot change it into, use.
I just couldn't figure out how to.
Right. So this is natural log x, and this is x. And they never cross, right? We try to find an x-intercept. They never cross because x goes faster than this. That's the reason why this will be infinity. Okay? So coming back here, from infinity to 1, yes, it decreases. From 1 to infinity, yes, it increases. So now let's look at the second derivative, which is even easier than the first. But of course, I will differentiate this, not this, this. So the second derivative is 1 over x squared. Always positive, as expected. Okay, so it opens up. So this is an absolute and local min. Okay, so now I'm ready to graph the function. So I have at 1 is 1. So it has a vertical asymptote, which is x equals 0. So it's coming from positive infinity, opening upward, and it goes to positive infinity, of course, opening upward. So this is the function f of x equals x minus natural log x. So with the graphing calculator, we can double check. So when I look at the viewing window, I don't need more than -1 to 1. I'm sorry, -1 to, I don't know, 20, let's say. And y minimum -2 is good enough, and y maximum, I don't know, let's say 30 with a scale of 5.
So the quiz, when I took the derivative, I realized that 1 minus 1 over x, as x approaches infinity, the slope becomes 1, which is kind of the same slope as x. So I just drew y equals x to represent that.
I'll take a look. So this is the graph. Any questions?
Can we go back to your chart?
Oh yeah. Good. Now I would like to select from optimization. So one more time. Finding max min on a closed interval. This is what we had in one of these quizzes. Is that okay? Mean value theorem and Rolle's theorem. Are those okay? Graphing.
I don't know why. I've just never really been good at graphing, I think that's an issue. But I'm trying. Like,
Okay.
I'm at home trying to, like, practice with the limits and everything.
Okay.
And to me, it's like the picture comes pretty easily, but it's just that I'm gonna have to work on like showing.
Yeah,
everything.
yeah, you have.
Yeah,
Yeah.
that's my issue.
So grabbing the calculator first and looking at the graph is not a good idea. It's not a good idea. And then trying to fix things in there. Okay. Newton's method. Are we okay with Newton's method?
So
L'Hopital's
the function is x minus f of x
Over
divided
f
by
prime.
f prime of x.
Yes.
Okay.
And you have to make sure that if you pick a number, a value of x, that makes the denominator 0, you're not going to get anywhere.
Right.
So you have to make sure that you do not pick a value that makes f prime 0. Because you're not going to get not even the first step. It will be an error. And this happens if there is, which is not going to be the case. It's very unlikely. But if you pick x0, so you have the root here, and you pick x0 here, and there is a max or a min between the root and the initial value, the method will never converge. It will stay here. It will never get here. But that's not going to be the case. It's unlikely, right? Because you're going to look at the 1 unit interval. You're not going to pick 10 if the solution is around 0, right? So that's very unlikely. And then L'Hopital's rule. Are we okay with L'Hopital's rule?
I think so.
Okay. So just optimization is the one that we have to practice then for the rest of the class today. Is that okay? Okay. Let me see. Okay. So on page 333, I selected a few, and of course you can select more. I think 33 is interesting. 34 it looks interesting. 35 looks interesting. 43 looks interesting. 42 looks interesting. 38 looks interesting. Please choose.
Doesn't matter to me. You have a whole list. Let's just go.
Okay, very good.
Let's just do it.
Let's start with 35. Only because it's in red. A piece of wire 10 meters long. Okay. Is cut into 2 pieces. One piece is bent into a square, and the other is bent into an equilateral triangle. How should the wire be cut so that the total area enclosed is a maximum and then a minimum? One more time. a piece of wire 10 meters long is cut into 2 pieces. So I cut it right there. One piece is bent into a square. So I bend this into a square. And the other one is bent into an equilateral triangle. Fine. How should the wire be cut so that the total area enclosed is max min? So what is my first concern? That I need to find a function that represents the total area of these two, that later on I will da 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 da, right? I will differentiate, set equal to 0, find critical numbers, blah blah blah. So my first concern is to express the total area as A1 plus A2, this being A1 and this being A2. So that's my starting point. Would you agree so far? Okay. Then I will say, I will have to denote this by X, and I will have to denote this by Y. Now I have the area of this square. What will the area of the square be? Good. Which means that, what is this length? Thank you. Plus, now with the area of the equilateral triangle, I have to work a little bit, do some work a little bit on the side. I know that the equilateral triangle has all 3 sides that are equal. I know that this is the height. And I know that it divides, it's not just the height, but it's also the vertical line that divides the base into 2 equal parts, because everything is equal here. So then, in order to determine the area of this triangle, I will have base times height divided by 2. However, I do know these angles. What are the angles equal to in an equilateral triangle? 60. So I have to find the height. So in this right triangle, I will say, let's say tangent 60 degrees is h over y over 2. So this is y over 2. H over y over 2. I can use sine if you want sine. Sine 60 degrees equals h over y. Whatever you want to do. But I have to get y from here. I have to get h from here. So h equals y sine 60. So I'll go back and put it in. So I have A2. A2 is y times y squared times sine 60 divided by 2. Finally, I have a function, y squared sine 60 divided by 2. So then, how much is this? Very good. So I have another equation. What equation I have now? I have that 4x plus 3y equals 10. And I have that the total area is x squared plus y squared sine 60 over 2. I have to do something about these two because I don't know how to differentiate a function with 2 variables.
Solve one for x and plug it into the other.
Exactly. So I'll solve this one for y and plug in x. Because it's easier to plug in here than to plug in here and also have that. But it's the same, of course. There is no big difference. So from here, I'm going to say y equals 10 minus 4x divided by 3. Therefore, that's not what I meant, of course. X equals 10 minus 3y over 4. So then a is a function of y. I'll square this. So I have 100 minus 60y plus 9y squared over 16 plus y squared sine 60 over 2. And now I can say this is a function with only one variable. Any questions on what we just did? It's not done. I only have the function that represents the total area. So I do have, let's summarize. I do have 4x plus 3y equals 10. I do have the area of this, which is x squared. And I have the area of this, which is y squared sine 60 over 2. So now I solve this equation for x. So I have 10 minus 3y over 4. And I plug it in x squared. So I have to square. The denominator is 16, and the numerator, the first term squared minus 2 times the first times the second minus 60y plus the second term squared. So now, what do I need to do? So I finally, after all this effort, I have a function. It's a function of one variable, and now I need to find its max, and I need to find its min.
Could you
Yes.
get a common denominator to add?
Oh no, I don't need that.
You just take the
I will just differentiate. Can you? Yes.
Oh.
But it will be more work. Okay?
Can I take a look?
Yes, please. Yes. So a prime will be a prime of y. 100, so I only differentiate the top because 1 over 16 stays in front. This prime is 0, this prime is negative 60, and this prime is 18y. Plus 2 with the 2 will go away, plus y sine 60. So this is our a prime. What do I do with it?
Set it to be 0.
Right. So a prime.
So what we're doing now is we're building that chart, right, with the f prime of x, or,
Just a prime and a,
right,
because I need to show. But once I have the critical number,
right.
or the critical numbers, I don't know, and then I'll put them in the chart. But just the first two, just
Right.
a prime and
So
a.
we don't need all of it, it's not graphic. It's
Right,
just-
exactly. We are not asked to even find how should the y be cast of the total area enclosed. Yeah, we have to find. I need both rows, a prime and a, because we're asked to do that. Okay, so when I set this equal to 0, I'm going to distribute negative 60 over 16 plus 18 over 16y plus y. I know that sine 60 is the square root of 3 over 2, and I set equal to 0. I will move this to the other side and factor out y. 18 over 16 plus the square root of 3 over 2 equals 60 over 16. So then y equals 60 over 16, 18 plus 8 the square root of 3 over 16. So these two go away. So y equals 60 over 18 plus 8 the square root of 3. I'm using my calculator to see what that is. So this is 60 divided by, don't forget parentheses, 18 plus 8 the square root of 3. And I got roughly 1.88. So y equals 1.88 meters. Of course, this doesn't mean anything just yet. So I have y. Good. So, and this is a prime, and this is a. Okay. Y is the length of the side of the equilateral triangle, right? That is y. What is the minimum possible y?
0.
Right.
It has to be a-
Right, which means I use the entire 10 meters to make the square. Okay, so it can be 0. What is the maximum possible y?
3 1/3.
Right, because it means that I don't have the square, And the maximum possible will be 10 divided by 3. You'll agree that this is the domain of this function, for sure. Okay. So this is 1.88. This is 3.3 and 1/3, right? 3.33. Good. So this is 0. And now I have to study the sign. Of course, I will have to determine this. I will have to determine this, and I'll have to determine this for A. So now I need to study the sign of this function. When I plug in 0, this is 0, this is 0, it's negative. So what will this give? An absolute minimum, right? Right. So when y equals 1.88, that will be, and we'll find the values in a minute, that will be the absolute minimum possible area. And we'll see when the maximum is. So with the calculator, where was, okay, here it is, right here. Let me do this, it's easier now. Okay. So, parentheses, 100 minus 60x plus 9x squared. Close the parenthesis and divide by 16 plus x squared. And in parentheses, I have just making sure that, for a moment I was afraid that I forgot about that too in the denominator, but I differentiated it. Okay, and they have the square root of 3 over 2, so this is the square root of 3, and divide, no, not there. Not there.
Yeah, delete it.
Okay, thank you. And divide by 4. Okay, so now second and table.
Wait, divided by 4?
Yeah, because I put the square root of 3 over 2 over 2.
Oh.
Yep. So I want 0, and I get 6.25. I want, what is my chart? What did I do with it?
3 1/3.
Oh, it's up here, hiding. So 1.88. And 10 divided by 3. Okay. So as expected, this will be this 2.71. At 0 is 6.25. And 4.8. So down and up. So I know that this is the absolute minimum when y equals 188 meters and x equals, I have to calculate x. So 10 minus 3 multiplied by 1.88, and at the end, after I calculate, okay, 1.09. And x equals 1.09 meters, absolute minimum. And what is the absolute max? Indeed, when y is 0 and x is 10 divided by 4. Yes. And the absolute max is 6.25 squared. What was the whole thing given in? Meters. Yeah, right. Of course. So the area here for area maximum, max, is 6.25 square meters, and here the absolute min, area min, 2.71 square meters.
Well, I have a question.
Yes.
If the one piece, so the directions say you have to cut it into 2 pieces.
Yes.
So can one piece be 0? Because that would mean you only
No,
have
you're
one.
right, but the question
So I guess it would just be like a
find
approaching 0.
no. It says how should the wire be cut so that the total area enclosed is a maximum? Well, we should cut the wire by not cutting it, actually, and we should just bend it all into the square.
Okay.
And at a minimum, if we want an area to be minimum, we should cut it so that the right-hand side is 3 times this, and the left-hand side is the remainder. So for the area minimum, use all 10 meters for the square.
So that's the
Oh,
area
the
max.
maximum. And for the area minimum, use 3 times 1.88. 3 times 1.88, and subtract it from 10. So 5.64 meters for the triangle, and 4.36 meters for the square. Any questions on this problem? Any questions on this problem? Okay, let's look at 43. If a resistor R in ohms is connected across a battery of E volts with internal resistance R ohms, then the power in watts in the external resistor P is E squared times R over R plus R squared. If E and R are fixed, but R varies, so fixed and so uppercase E and lowercase r are fixed. So they should, for simplicity, I would have written P of R, which is very clear now that the only variable is uppercase R. So they're asking us, what is the maximum value of the power? Three minutes.
Oh, you want us to?
Time is ticking. 3
Okay.
minutes.
Oh, did you want us to explain it? Or?
Yes. No, I want you to determine it.
Oh.
You don't need my help on this one. So you have an example of in the application of electricity, and then we can look at an application of force, magnitude of a force, and the coefficient of friction.